3, 2, 1. Alright, so on the first one, not everyone, but a lot of you knew what you were supposed to solve. So on number 1, I have two side lengths. So because I have two side lengths, you get a grade for this, Ali. Because I have a grade for two side lengths, which method would I use? There's only two. And you should have them both in your journal. I actually gave everybody a grade. The first one is isosceles right. That's when you have tallies or 4590. Do you have tallies here? No. Look at the other method I showed you. When you have two side lengths, do you have two side lengths? Eric, do you have two side lengths here? What are they? What's one of them? Which one? 20. What's the other one, Salomo? Which one? No, 90 is not one. 19, yes. You have two side lengths, so we use Pythagorean theorem. Please write this down. Please write this down. This is a grade for today. Please write this down. Yes, Ali, including you. We use Pythagorean theorem because page 52, Ali.
What?
52, Ali. Because we are solving for a side, and we are given two side lengths. For someone who has 100, you don't know what to write. You have two side lengths, 20 and 19, so you use a squared plus b squared equals c squared because you have two side lengths. Now, on number 2, you remember I've only shown you one of two methods. On number 2, do you have two side lengths on number 2? I'm going to show you this in a minute, but I need you to look at number 2 for a minute. Do you have two side lengths on number 2? Bahiti? Do you have two side lengths? How many side lengths do you have, Magdalena? Just one. But what do they give you on number 2, Yusuf? What's different? What did they give you in the triangle? Exactly, the tallies. So, Sitlali, when you have two tallies, what kind of triangle is that when you have two tallies? Exactly. When you have two tallies, it's isosceles. So what do you use on this one, either Eric or Emily? What are we going to use on this one? When you have two tallies and it's isosceles right, what can you use because it's isosceles right? Which is called the what? What's the method? This one is the first method is Pythagorean theorem if you have two side lengths, which we don't. So can we use the shortcut? There's only two things we've done in here. I don't understand sometimes. Isosceles right. Do you have two tallies? Yeah, so you can use the isosceles right shortcut. Because it's an isosceles right triangle. I'm going to give you some time to write this one, then we're going to look at number 3, sorry. So this is where you either multiply or divide, you use a shortcut. There's a lot of off-task conversations, not a lot, just one. This is the stuff that doesn't help you later when I ask you questions and you don't know the answers. No, I don't. Okay, I'll have this up here for you in just a minute, but I need you to look at number 3. Look at number 3. There's only two methods I've shown you. The first method, Ali, which by the way I told you to put your laptop away and you didn't. The first method I showed you was Pythagorean theorem. You have to have two side lengths. Fernando, do we have two side lengths on number 3? Fernando, Do we have two side lengths on number 3?
No.
Can you let him answer, please?
No.
How many, which one, what is the side length on this one, Ahmed?
20.
20 is inside. 20 is an angle, Ali. Emily, can you tell me the side length on number 3? So you have a side length and you have an angle. You have a side length. Please write this down. Please write this down. Please write this down. We have an angle. An acute angle, not just 90. And one side. So, can I use Pythagorean theorem on number 3? Vote thumbs up, yes. Vote thumbs in the middle, I don't know, or thumbs down. Vote in 10. Can we use Pythagorean theorem like number 1 on number 3? Can we use a squared plus b squared equals c squared? Vote in 10, 9. You're saying no, why not, Citlali? Exactly. Can we use a shortcut like on number 2? You say yes. Citlali said no. You said no. Okay, why do you say yes, Ali? Why can we use a shortcut?
No, we can't use it.
Okay, we don't have the tallies. We don't have 45. So, for number 3, I'm going to show you how to do number 3 today. Number 3 is your ticket out today. We are going to use... it's called trigonometry. That's something new. We're going to do that today. Trigonometry. Please write that down.